All right, 1.4. Oops, not 4.1. So 1.4. So this is an important section. Why? And they're all important. But a lot of what we're learning in this section uh, will be a baseline for a lot of what you do if you choose to take calculus. Okay, it's something you're going to be hearing over and over again when you take calculus. So let's start with this first definition, which is pretty basic, right? So when is a function increasing? There's a definition right there. And as you can tell in this graph right here, we have f of x of 1 and then f of x of 2. And we'll call this the inputs of x of 1 and x of 2. And all it's saying is that if x of 2 is bigger than x of 1 and the outputs of x sub 2 is bigger than x sub 1, then it's an increasing function. Okay? And then the opposite for the second definition for decreasing. If we have the output of x sub 2 is less than the output of x sub 1, therefore that function is decreasing. And then finally, the definition for a constant, or when a function is constant, is when the inputs for x sub 1 and x sub 2 get no change in output from there. And down here, we have an example. Down here, we have this function f of x is equal to negative x cubed plus x. I graphed it for you. We're going to talk in our definition below, but this value is called a minimum, and it's at x equal to negative 1, and we have a maximum at x equal to 1/2. And then, so as we can see here, the function is decreasing here. The output values are getting smaller and smaller. And then it changes from decreasing to increasing between here, and then it goes decreasing again in values. You're still using interval notation, that's still applicable, you're still doing that. These are four important definitions you need to write down. Pause this video, write them down. Some are pretty straightforward in terms of like max and min, greatest and least value on some interval. Also, points of inflection. Best way to talk about points of inflection, this is less obvious. You know how whenever a parabola faces up, that little curve shape it has? That would be when it's facing upward. And whenever the parabola is facing downward and has that certain curve shape, that's whenever it's facing downward. So point of inflection is when it's changing from upward to downward or vice versa. So here we have a function right here, and we're going to label some of these parts, okay? I'm going to show you in class, and when it says relative maximum on a calculator, maybe you've already been shown how to find relative min and max on a calculator, maybe you haven't, but I'll do that whenever we are in class, and we'll write down the steps together on how to do that. But if you're all good on that, go ahead and punch function in, and you're going to get this. Now, I already labeled some of the mins and maxes. Now we're going to give them names, okay? This right here is an absolute max. Absolute max. I know it's a terrible T, I'm sorry. Absolute max meaning it's never going to get higher than that point on your graph, ever. Okay, so that's why it's an absolute max. As opposed to this maximum right here, we call a relative max. And why is that a relative max? It's relative to that specific interval. Okay, it's not the absolute max. There is bigger values in this graph, but for a given interval, that is the relative max. And this right here would be called a relative min. Is it the absolute min? Absolutely not, because the graph, as you see, has two arrows pointing down to infinity. I'm going to positive infinity and negative infinity. So this is a relative min. For its given interval, it's the smallest it can possibly be. Okay. Yes, there can be a relative max. Is there one for the, or excuse me, absolute min? There is no absolute min in this problem, though. Okay. Because it's going down to infinity. Okay. Now, if this was both these arrows are facing up, then we would be having our absolute minimum somewhere. And here is the average rate of change formula. Okay, all you're going to do is take the result of the outputs and subtract them, divided by the inputs and subtract them. Just make sure that um, these two line up. Okay, we can't mix and match. Okay, you might see this formula similar. It is similar to slope. Okay, so what are you doing slope? You're finding the average change of a linear line, right? Same difference with the average rate of change. Okay, you're finding the average change between two different points on the graph. All right, so we're going to do this one on the left first. F of 3 minus F of 2 over 3 minus 2. I did the formula. And F of 3 is equal to 2, and F of 2 is equal to negative 4. And then 3 minus 2 is 1. So then when we have 2 minus negative 4, I'm going to get 6 over 1, which is 6 for your solution. And then for this other one, so the end value was negative 3, the starting value was negative 5, and so once again, formula time. F of negative 3 is 115, and F of negative 5 is 455. So subtract, you get negative 440, but remember you have a denominator difference of 2. So actually it's dividing this one, and you'll get negative 220. I appreciate you watching, and I will see you in class.